All right, so now we're going to graph our square root function. We have g of x is equal to the cube root of x minus 3 plus 6. All right, so let's talk a little bit about our parent function here. We see our parent function. We've already graphed that. The parent function's point of symmetry was 0, 0. It went through 1, 1, negative 1, 1, or negative 1, negative 1, and also went through 8, 2, and negative 8, negative 2. So let's look at our transformations that have occurred here first, and that'll give us an idea of where our point of symmetry will be, and a little bit more about our domain and range. So let's think about it. Our transformation, we have x minus 3. That tells us we're going to go to the right 3. It also tells us that we have a k transformation out here. Let me use blue for that to be consistent. So that is k equal to 6. So we're going to go up 6. So starting from our point of symmetry originally, I'm going to go to the right 3, 1, 2, 3, and then I'm going to go up 6. 1, 2, 3, 4, 5, 6. And this is now going to become my new point of symmetry. My new point of symmetry will be 3, 6, based on my transform function. Now, the nice thing is, no matter what I do with this function, my domain and range are not going to change. So we're actually going to go ahead and we're going to plug this into our calculator first to kind of see what it looks like and then compare. We'll leave the parent function in there just because we always have been. We'll put the new function in here. And just like that, it appears. So I have both my functions in there. Let's take a look at how they look. Again, our parent function. Our transform function, it's going to start up a lot higher. We see there's a shift to the right as well. And so we see our point of symmetry has moved from here to there, which corresponds to moving up 3 and to the right 6. Let's go look at some points then that I can graph. So I'm going to go to my table now, second table. I see I can go through the point, and again, I'm going to look at y2 here. So I'm going to ignore y1 for the moment. I see I can graph the point 2, 5. We've already graphed 3, 6. So let's go ahead and graph 2, 5. 1, 2, 1, 2, 3, 4, and 5. If I'm really smart, I should be able to, I kind of see the trend here. If I went to 2, 5, I'm probably going to end up at 4, 7. Let's go ahead and verify that. 4, 7. Okay. See if there's any other points I can graph. I see I go through the point negative 5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay. Oh, that would be 5, negative 5, 4. So it'd be negative 1, negative 2, negative 3, negative 4, negative 5, 1, 2, 3, 4. Always watch that. See, the point down here would not have made that a simple transformation. So I can now draw on my graph here. Again, like I said before, any x values will work. So my domains, my interval notation would be negative infinity to positive infinity. My set notation would be such that the set of values for x go from negative infinity being less than x to x being less than infinity. For my range, we're going to have a similar process here, all y values. I'm going to end up with any possible y value as an output at some point in time. So my interval notation, again, is going to be from negative infinity to positive infinity. As x becomes more negative, my y is going to continue to become lower. As x becomes more positive, my y value is going to increase. So I'll go from negative infinity to positive infinity. Our set notation, again, is given by the brackets. Y, the set of y values range from negative infinity being less than x, or sorry, from negative infinity being less than y, through to y being less than infinity. Okay. We've already labeled our transformations. We've graphed our new function. Let's label this g of x here, and there we go. Now let's take a look at this next function. G of x is equal to negative 3 times the cube root of x plus 1 minus 4. Now, because we're going to see our transformations are a little bit different, we're going to have to make some other changes as well here. So our a value is equal to negative 3. This tells us a couple of things that are going on here. Not only do we have a reflection, so we're going to start low or start high and end low, but we also have a vertical stretch by a factor of 3. So this is going to be the transitions from top to bottom will be much greater than it was here going from bottom to top. So it's just going to be wider, if you will, okay? Or vertically stretched, okay? So we'll take a look at that. We see that we have this x plus 1 under the radical sign. That is going to tell us we're going to go to the left 1. And then looking outside the radical sign or after the radical sign, we see this minus 4. That's our k value. So we are going to go down 4. Since my original point of symmetry was at 0, 0, and I have a transformation to the left 1 and down 4, my new point of symmetry will be negative 1, negative 4. And I can go ahead and graph that. So negative 1, down 4, 1, 2, 3, and 4. That will be my new point of symmetry. Now again, I should start high and finish low if I do this correctly. So let's go ahead and enter this into our calculator. Our values are now into our calculator. We're going to graph it, zoom 6, just to kind of see how it looks, to make sure our assumptions were correct. We see our first function, our parent function, and then we see the second function here, the g of x, the transform function. Starting high, finishing low. We see our point of symmetry at negative 1, negative 4, representing the vertical and horizontal transformations. At this point, let's go ahead and find some other points that we can graph. Go to second graph. Again, we're going to ignore our y1 column here. That was from our parent function. We see at negative 1, we have negative 4. We graph that. We see we go through the point negative 2, negative 1. So we'll go ahead and graph that. Again, we would expect that point to be higher than the point of symmetry. Other points we go through the point 0, negative 7. So we can graph that. And if we want to at this point, we can try to find some other values that maybe we can graph with. That would be on the graph. But we see that the next point we possibly do is negative 9, 2. So we're not going to be able to graph that. The other points are going to be too low. So yeah, we're pretty much done with what we can graph on here. So we're just going to sketch it starting high and finishing low. Okay, and that's a pretty good graph or sketch, I should say, of our transformed function. The only thing we have to do now is our domain and range. Again, nothing has changed. We're still going to cover all x values. We're still going to cover all y values. So our domain is negative infinity to positive infinity. Or I can say the set of all values for x is from negative infinity being less than x, which is less than infinity. For my range, my y values go from negative infinity also to positive infinity, or the set of y values range from negative infinity being less than y, which is less than positive infinity, and that would also be my range. Now, in this case, we're both going to be given the transform function, and we need to write the equation for the transform function. So we're going to work backwards from the graph to the transform function. In both cases, I'm going to draw in the original function here. Okay, and drawing in the original function here, we're going to go through the point 0, 0, 0, 1s, and then 8, 2, and 8, negative 2. So this would kind of be the original function. So let's think about what we did here. First, we're going to go and we're going to look at how our point of symmetry moved. That will give us our h value and our k value. Okay, so our point of symmetry normally went through 0, 0. Now our point of symmetry is here. So I went to the right 2. because I went to the right 2, I'm going to have under the radical sign x minus 2. Now I'm going to shift vertically downward, and I go down 1, 2, 3 to get to the point of symmetry. That means my k value is equal to negative 3. I see as my graph, from my point of symmetry to my next point, I go up 1 and over 1. From here, the point of symmetry to my next point, I go up 1 and over 1. We see that there is no vertical stretch or compression. There's no reflection. So therefore, a is equal to 1. With that in mind, my function then g of x is just equal to the cube root of x minus 2 minus 3. I put the graph now in the calculator. I look at it with the function such that what we came up with was the cube root of x minus 2 minus 3. When I graph that again, I get a graph that looks awfully like the transform function I was trying to imitate. And I go to my table, and I see that my point of symmetry goes through 2, negative 3, which is the coordinate for the point of symmetry. Here, I must have done something right. Looking at the next example, again, I'm going to draw on the parent function 0, 0, 1, 1, 1, 1, 8, 2, and negative 8, negative 2. Kind of sketch it in. Let's do our vertical and horizontal transformations from the point of symmetry. It looks like I'm just going to go over 1. So that means I'm going to go to the right 1, which means I'm going to have the cube root of x minus 1. I'm going to do a vertical transformation up 1, 2, 3, 4, and 5. So my k value is going to be equal to 5. Now, we don't see any reflection, so we have no reflection. So a has to be greater than 0. We do have a stretch. Notice that from the point of symmetry to my next point, I go up 2 and over 1. In my original equation, or my original graph, I would go up 1 and over 1. So my vertical stretch, since I go up 2 and to the right 1, means that a is equal to 2. That would be my vertical stretch. So my equation then is g of x is equal to positive 2, because there's no reflection, multiplied by the cube root of x minus 1 plus my vertical transformation of 5. Let's make sure we did this right. We put our function in there, 2 times the cube root of x minus 1 plus 5, and we go ahead and graph it. And we see that it looks exactly like the graph here. This, our transform function, looks exactly like what I've graphed in the calculator. Therefore, I know that I've come up with the right solution.